Hello, this is checkpoint 5.7 from section 5.2. In this problem, they want us to use a definition of the definite integral to evaluate this integral, the integral from 0 to 3 of 2x minus 1 dx. They want us to use the right endpoint to approximate, use the right endpoint approximation to generate your Riemann sum. So the right endpoint approximation will have this, and x sub I should just be, this x sub I star should just be x sub I. So x sub I star is the notation that they use in general to represent any point within the little subinterval. This could be x sub I, could be x sub I minus 1, or it could be somewhere in between those two, like the midpoint or something else. But the right-hand endpoint would just be this. You can also shift this to be the left-hand endpoint by starting from 0 and ending in n minus 1. But regardless of how we look at things, we'll just use this as a formula because this will be our right-hand endpoint formula. Now we're going to need to translate a few of these other terms here into something that we can work with within the sum. So for example, we don't know what delta x is yet. We don't know what x sub I is yet. And then I think those are the main missing parts. And so we'll start with the delta x. It turns out that the delta x is actually equal to b minus a. And so in your integrand, you're going from, or your integral, you're going from 0 to 3. So your b is equal to 3, your a is equal to 0. And we're going to divide it by n, and here they don't give us a specific value because we're not approximating it. We're going to get an expression here that has an n in it, and then we're going to take the limit as n goes off to infinity. After we do that, we can figure out our x sub I. X sub I, it's going to start off with x sub I plus the shifting in the delta x, so it's going to be the first lower limit term, so that's the left side of your big interval, and then you're going to add delta x to it. That's for the first one, and then for the second one you're going to add 2 delta x's. For the third one you're going to add 3 delta x's, so you're going to add delta x times however many times you want to move from a. Okay. In this particular problem, a is equal to 0. Delta x is 3 over n, so this is going to be 3i over n. And that is going to be our x sub i's. And we know that this is 3 over n. Okay, now that that's settled, we can set up our integral. We know that our function, f of x, is equal to 2x minus 1. Again, your delta x is given here. Delta x is going to be 3 over n, and x sub I is going to be 3i over n. All right, let's go ahead and start our definition and our sum. So our integral is going from 0 to 3 of 2x minus 1 dx, and this is going to equal to the limit as n goes off to infinity of the sum. I goes from 1 to n of the function 2 times x, which is 3i over n minus 1. And then that takes care of this part, and then we need our delta x, which is 3 over n. Okay, this is the sum that we're going to be working with, and then after that we'll take the limit. So we'll break this up into a couple of pieces. We'll say this is going to be the limit as n goes off to infinity of the sum. Let's multiply this out. I goes from 1 to n of 3. This is going to be, this is 9 times 2 is 18 I, and then in the denominator n times n, so that's n squared minus 3 over n. Okay. I think at this point we want to try to remember some of the important limit or some of the important series formulas that we had. We have the series 1 to n of 1, which is equal to n, and the series I goes from 1 to n of I is going to be n plus 1 divided by 2. So if you remember those from some of the earlier discussions in this chapter, we will use that here. Let's take this apart a little bit. And we're going to take the limit of a couple of things. Let's split this up into two series. The first one is going to be 18i over n squared. And what I'm going to do is I'm going to consider I here as the variable because that's what the index is. So everything else is constant with respect to I. So the 18 over n squared is constant with respect to I. I goes from 1 to n of just I. So we took the 18 over n squared out. And then we have a 3 over n that we're adding up also, but that's constant as well, going from 1 to n of just 1. Okay. So what we did here was we took the constants out so that we can just focus on a couple of formulas that we will be using to figure out these things in terms of n. Okay, here we have the limit as n goes to infinity of 18 over n squared. And then this expression here is going to be n plus 1 divided by 2. And then here we have a 3 over n, and this expression here is going to be equal to n. That's the first one. All right. Now we can simplify things a little bit. There's an n squared in the denominator, cancel with this n, and we have an 18 over 2, which is going to be 9. Limit as n approaches infinity of 9, and then we have an n plus 1 over n. That's what's left over, and here we have a minus 3. All right. Now we'll take the limit as n plus 1 over n goes off to infinity, and since these are a couple of polynomials with the same power, that's just going to go to 1. You can use L'Hopital's rule or whatever. So this is going to be 9 minus 3. All right, and so our final answer is 6. And then that's it. So remember the formulas for delta x, the formulas for x sub I, and then a couple of formulas. If we had something that was squared, there's another formula for the sum of I squared. And then as you're breaking this down, you should expect your n's to cancel out, or taking the limit, and then it'll be something that would be a finite number. And this ended up being 1, so we have a 9. And then this had no n, so that's just a 3. All right. I hope that helps. Good luck.